Solving equations and discussing the techniques for solving equations is one of the most important themes in mathematics. We're going to start the idea right now. We already know that the idea of solution is a value of a letter that will cause the statement of equality to be true. So in this equation, we're looking for a value of x so that the replacement for x plus 4 will be equal to 9. That number, of course, is 5. So 5 is a solution to the equation. Now, the technique for solving this kind of equation is one where we're going to just try to manipulate the equation to make the equation tell us the value of x that is the solution. Now, to do that, we simply think of this statement of equality as being a balanced situation. That is, the number over here has the same value as or is equal to the number over here. And we consider the idea that if we add or subtract over on the right side of the equation, we have to add or subtract the same amount on the left side of the equation to maintain this balance. And if we just keep that in mind, then we're pretty safe in performing operations. That is, we perform operations on both sides of the equation. Now here we see that x plus 4 appears here. So we're adding 4 to x. We'd like to eliminate this 4. How can we undo the addition of 4? You see, the opposite operation, the inverse operation of adding is subtracting. So we could subtract 4 on both sides of the equation to accomplish this task that we're talking about. That is, we can do this. We can bring down x plus 4 and subtract 4. Then if we subtract 4 on the left, though, we have to subtract 4 on the right. So we would write 9 minus 4 on the right. Now, 4 minus 4 is 0 on the left, and x plus 0 is x. So x then is equal to 9 minus 4 is 5. You see, we have made this manipulation so that we make the equation tell us the solution. It's just an isolation process. Now, I know we can see the solution in this problem, but maybe we can't see it so easily in a problem like this. We have y plus 17 is equal to 42. We want to clear the 17. We want to make the equation tell us the value of y that will solve the equation. And we do that by just undoing this operation of adding 17. And we can undo that operation by subtracting 17 on both sides. So we would write y plus 17 minus 17 equals 42 minus 17. Now notice that all we're doing in writing this step is we're writing this side down and show that we're subtracting 17. Write down the right side and show that we're subtracting 17. We're doing the same operation on both sides of the equation, and that's a very important point here. The 17s go out as expected and we're left with y. On the right, 42 minus 17 turns out to be 25, and 25 is a solution to the equation. Now we can always check to see if we have a valid solution to equations like this. We're just checking to see if this is a solution. We check by taking the original equation and replacing the letter with the value we find for it. We're finding the letter to be equal to 25. Well, let's replace y with 25 and see if we have truth. Well, let's see. On the left side, 25 and 17 is 42. 42 equals 42. Yes, 25 is a valid solution to this equation. Now, let's consider this one. Now, in this one, notice that the variable is on the right side of the equation rather than the left side. There's no difference there in our concept for a solution. We're still trying to isolate the letter on one side. We'll just isolate the letter on the right side here and make the equation tell us the value of that letter that'll make this true. We're trying to clear the 12 this time. To clear the 12, we'll subtract 12 on both sides. So we'll write 33 minus 12 on the left, and on the right we'll bring down the expression that we see and we'll show that we're subtracting 12. On the left side, 33 minus 12 is, let's see, that would be 21. And on the right side, the 12s go out. Now, I know the 12s go out because I can use the commutative property, you see, of addition. Swap these two and I would have 12 minus 12 here. I'm using the commutative and associative properties here to accomplish this idea. But we can see through it rather easily. 12 minus 12, 0. And we're left with v. And once again, we can replace v with 21 in the original equation to verify we have a solution. Sometimes the check can be done very simply by observation. We can just look up here and imagine the 21 replacing the v. You see, put a 21 up here, and then imagine 21 and 12. Oh, that's 33. 33 equals 33, a true statement, and therefore a valid solution. Now, another kind of equation is one where we have an indicated product involving a letter. And here we have that situation. 4x means 4 times x. So 4 times x equals 12. We're looking for a replacement for x that'll make this true. 4 times what number is 12? Of course, we know that number to be 3, but we're going to go through a manipulation not too unlike the one that we did before to isolate the x. Now, we see that we're multiplying, and to undo multiplication, it makes sense, or it should make sense, that we divide. And we see that we're multiplying by 4, so does it make sense that we're going to divide by 4 in order to clear this 4? Here's what we do. We show that we're going to take 4x and divide by 4. We're going to take the right side and divide by 4. You see, just perform the same operation on both sides. These 4's will divide out. They take each other out. They cancel, if you will. And we have x equals 12 divided by 4 is 3. Now, is 3 a valid solution? Well, we can tell by replacing x with 3. 4 times 3 is 12. 12 equals 12, a true statement. Let's try another one. We have 12n equals 60. We'd like to isolate the n. We have 12 times n. The inverse operation is division, so we'll show that the 12 is divided on both sides of the equation. So we bring down each side and show that we're dividing by 12. These 12s cancel, leaving n, and on the right, 60 divided by 12 is 5. And is it the case that 12 times 5 is equal to 60? 12 times 5 is 60. 60 equals 60, a true statement, so a valid solution. Word problems can lead to equations which we solve using these techniques. This says the product of 5 and a number is 45. The product of 5 and a number. Now, when we begin to build an equation to solve word problems like this, we are interpreting the words that we see in the word problem. And so as we go through and as we encounter situations that we understand, we might begin to write things down. For example, when we see the word product, we know that this is the answer in a multiplication problem. And we can then identify the items being multiplied. The product of 5 and a number means 5 times a number. Now, all we need to do is let some letter stand in for the number. Let's say it's n. So the product of 5 and a number n would be 5n. All right, there's the product of 5 and a number. Means is equal to 45. You see, we have built an equation here based on the words that we see. What is the number? Well, let's see. Let's solve this. We would divide on both sides by 5. These 5's go out, and we find n to be 45 divided by 5, which is 9. So n then is 9. Let me do this to separate these two. Here's another one. A number multiplied by 20 equals 400. A number, like OX, multiplied by times 20 equals 400. You see, now we have a similar situation. We have a number times a letter. Now, the number happens to be on the right side of the letter, but it doesn't really make any difference. We can write it the other way around if we want to by our commutative property of multiplication. That is, in the next step, I could write this as 20x and show the division of 20 in order to clear that 20 on the left side of the equation. But if I divide by 20 on the left, I have to divide by 20 on the right. Those go out, and we find x to be equal to 20. 20 into 400 goes 20 times. Now, we might go back and verify a number multiplied by 20 equals 400. The number we found is 20. Is it true that 20 multiplied by 20 equals 400? Go like this. Yes, that's true. So we have found that number. Here are some other word problems, and they lead to the other kind of equation that we talked about earlier. A number increased by 4 is 15. A number increased by implies addition. Increased by 4 is equal to 15. What is the number? We solve the equation. We solve the equation by isolating the letter, and we isolate the letter by undoing this adding of 4. We undo it by subtracting 4. So we bring this down, subtract 4. Bring down the right side, subtract 4. These go out and we're left with x. 15 minus 4 is 11. 11 is the solution to the equation. 11 answers this question. What is the number? The number is 11. The sum of, as soon as we see the word sum, we know we're going to add, because it's the answer in an addition problem. The sum of 11 and a number, 11 and a number is equal to 52. Find the number. By the way, the selection of x as the letter here is completely arbitrary. We can use any letter we'd like to for the unknown quantity. At any rate, we're trying to isolate the x. In this case, we do that by eliminating the 11, and we eliminate 11 by subtracting 11 on both sides. So we bring down the left side and show that we're subtracting 11. We bring down the right side and subtract 11. The 11s go out here. We have x equals 52 minus 11 is 41. So let's see, the sum of 11 and a number we found to be 41. 11 and 41. Is that equal to 52? Yes, it is. And so we have successfully found the number.